You've got VoIP phones, cameras, video monitors, devices that need to connect to your network, but they also need more power than batteries can provide. So where does the electricity come from? How do you get electrical power without installing outlets on each one of these devices so that they can still connect to your network over a layer 2 switch or switches? Enter Power over Ethernet, or PoE. What is Power over Ethernet? Why do we need it? And what do you need to know? So stay tuned. So you have a lot of devices out there that use power, but also need to be connected on a network. Things like cameras, VoIP phones, wireless access points, or APs for short, video monitors, motion sensors. The list goes on, and that list is growing by the day as manufacturers come up with new ideas for end devices. These powered devices very often need more power for longer periods of time than batteries can provide. But having a network cable connecting them to a switch for the data they provide or the function they perform, then installing expensive power outlets in walls and ceilings to provide each in-device long-term power can be expensive. Just running electrical outlets for 10 to 20 devices in a small building can run upwards of $20,000 all the way up to $100,000, depending on the situation. So what do we do? Enter PoE. Power over Ethernet. Essentially, power for these devices is provided over the copper Ethernet network cables, connecting them to the switch, and the power is derived from the switch they are connected to. Now, I'm going to give about a 15-second history lesson here to discuss where PoE originated. You see, Cisco, who still dominates the switch and router components manufactured and used in most networks, Cisco decided back in 2000 through 2002 and 2003 that they wanted to connect VoIP, voice over IP phones, more specifically IP telephony headsets, with a single network cable into cubicles and offices, and they wanted to emulate the old analog phones that got their power through their phone cord coming from the wall. They wanted VoIP phones to work exactly the same way. This required power to be provided through the Ethernet cable, just like it was through the RJ11 phone cables used on old landlines. Power over Ethernet, PoE, was developed initially for exactly that. Cisco began developing and manufacturing switches that could provide power over the Ethernet cable on the wires within the Ethernet cable that were not being used for data. The traditional PSTN, or public switched telephone network landline phones, operated by delivering 48 volts direct current or DC power over the same copper cabling used for communications. Those power lines use the RJ11 cable connectors, which look very similar to Ethernet RJ45 connectors. PoE initially took advantage of unused pairs of the 4 twisted pairs of copper wires found in typical Category 5 or Cat5 cable. In 1999, both the IEEE and the Ethernet Alliance started working to standardize PoE to ensure interoperability across a broader range of connected powered devices and power sourcing equipment. The first of these standards was IEEE 802.3AF, and it was ratified in 2003 and specified that the power must be able to be carried by either spare pairs, pins 4 and 5, or pins 7 and 8, or data pairs, pins 1 and 2, or pins 3 and 6. Now again, if you haven't seen my other video where it talks about the different cable layouts, the pin layouts inside the Ethernet cable, you might want to check this video out. So not to get too entrenched into the details here, but the standard also includes a mechanism to protect devices that do not support PoE. A 25 kilowatt resistor is added between the power pairs on the power device, and the power source provides power only if something close to that resistance or resistive value is detected. The overall value of PoE was quickly realized. Transporting both power and data across a single cable not only reduced cabling needs, but improved safety and simplified installation, thus saving time and reducing cost. The value of PoE, in turn, amplified the need for more power to support a wider variety of end devices, resulting in several additions and improvements to the 802.3AF standard. Once these standards and switches were developed, manufactured, and began to be sold across the board for use with VoIP phones, other device manufacturers began developing things like cameras, wireless access points, and even video monitors that could not only be operated over Ethernet cable connections to computer networks, but that would derive the power those devices needed also using PoE, or power over Ethernet. Now, You can look these up online and see that PoE started out with what is referred to as Type 1. Then it moved to Type 2, which provided 30 watts of power, and has quickly developed into Type 3 and Type 4 for use with providing even more power to bigger and more capable devices. If you choose to get into more detail and further investigation into PoE, you'll see that there are now switches and even routers and power injectors out there that can provide more customized PoE in their own configurations. For instance, on some of the newer Cisco and HP switches and routers, you can set priorities on different interfaces to prioritize power being provided to one or more devices connected on those specific interfaces over other devices that might not need that power. This can come in handy during storms and power outages to allow some devices to stop using power from the switch or router or the power injector, and for others to keep working. Which might lead us to ask this question: is this PoE technology safe to use, or can it damage my equipment? IEEE 802AF, AT, and BT compliant PoE technology is safe. PoE injectors and switches will not damage any equipment, even if the equipment is not designed for PoE applications. Before the PSE, which is the power sending equipment, sends any power to a connected power device, the PSE initiates a handshake procedure that establishes how much power the connected device requires. This procedure uses low voltage and is harmless to any connected device, PoE or non-PoE. If the handshake is completed, the PoE injector or switch begins sending power, which triggers the powered device on the end to start up. If that handshake is not completed for any reason, the PSE never sends any power out the cable. It is this built-in feature of all IEEE 802.3AF, AT, and BT compliant devices that makes PoE technology inherently safe. Which leads to this: since engineers and manufacturers are now making more and more devices that can utilize PoE to allow them to connect to a computer network and be installed just about anywhere, you're going to start seeing a plethora of unique technologies on the near horizon that only need to be provided an Ethernet cable from a PoE or power source piece of equipment. Things like home automation, better cameras and motion sensors. I've recently seen PoE Ethernet cable connections that power laptops and tablets without them having to use their own battery or power from a wall socket. But it gets even better. All of the devices that fit within the parameter of IoT, the Internet of Things, will start utilizing PoE more so than ever before. And IoT hasn't even yet reached the pinnacle of its estimated usage in society. You'll also see AI technologies developed that will use PoE to be more efficient, less hassle to set up or install, and highly more functional and useful as a result of PoE technology. So the future is looking bright for PoE, and it would be a really good idea to check into it, learn more about it, and really understand it if you're planning on getting into the computer networking field, either as a career or as a business.